Alright, 4.1, we are solving systems. And this is a new chapter, and this is the first time we've talked about what a system is. But these will have two variables, and so that's kind of nice, because later we'll get to them with three. But the first thing they do is they give you a point. For example, they could say, is this point a solution of this system? And they give you a system, and this is an example of a system. So a system is just two equations that are related, and so that's our system. So they want to know if this is a solution of this system, and we know this is a line and another line. So in order for this point to be on both this line and this line, they have to intersect at that very single point. And we'll actually find that solution in the next problem. But right now, we want to just decide if it is a solution or not. So all you have to do is plug it in and see if it's true in both lines. So I'm plugging x in, which is 4, in for the x right here. And y, 1. So I have 4 minus 1 equals 3. And we can see that, oh, yep, that's true. Now let's check it in this one. I have 2 times 4 minus 3 times 1 equals 5. So I have 8 minus 3 equals 5. And yep, that's true too. So our answer to this problem is yes, this is a solution of this system. So now they're going to ask us to actually find that solution. And so they'll say solve. And the first way they want us to do it is by graphing. So we'll learn 3 different methods, and the first one is graphing. So they just give you a system, 2 lines, like always, and then we know that if we have to graph it, we probably want it in slope-intercept form. So I'm going to make them look like that. So right here, I'll go ahead and subtract x from both sides. Right here, I just subtracted that x. And then I need to make y positive, so I will divide everything by -1. So I'm changing every single sign. And right here, I'll go down and solve for this y. So I'm going to subtract x and divide by 3. So I have this line and this line, which are the same as this line and this line. They're just written in a way that makes it easier for us to graph it. So, graphing it on a Cartesian plane now, let's graph this one first. We know that the y-intercept is -2, and hopefully this is all review, and the slope is up 1 over 1. So, those are my 2 points. And we want to try to draw these as accurately as possible, because we have to tell them the one place they intersect. Alright, then let's go ahead and graph this one. So I've got up 2, and that's my y-intercept right there, right? And then -1 over 3. So I go down 1, right 1, 2, 3. Alright, now notice I could have gone up 1 and left 3. And that would intersect at some point as well. But this is clearly our better option in this scenario, since our line is down here, rather than going. So, drawing my line now. Hopefully I can draw that pretty straight. I missed the point, but you've got the point where I should have gone right there. So you can see the intersection, and they won't give you like fractions and decimals, so kind of figure out what integer that point is on, and it looks like it's over 3 up 1. So that is the solution to this system, 3, 1. Now if you choose, you can check it, and we know how to check it because we just did that up here. So all we have to do is plug 3 and 1 in, and you can eyeball that and see it equals 2, and 3 in right there and 1 in right there, and see that that equals 6 as well. Alright, now let's try another method. Now we're going to solve using what's called substitution method. Now the substitution method, let's write down the steps. What we're going to do is we're going to solve for either x or y, whichever one's easier in either equation. And then we're going to sub that in to the other, make sure you don't put it in itself, into the other equation for that variable that you solve for. Then they'll only have one variable, and so you'll solve for that variable. And then we need our other coordinate. Like in a coordinate pair you have both x and y, so you'll put it back in, and you can put it back in either of your originals to get the second variable. Alright, so let's try one of these. So for example, here's a system. Alright, so I'm going to solve for x or y, and I look at this, and you could solve for any x or any y, but this one looks the nicest because it doesn't have a coefficient, so I for sure won't have any fractions. So let's go ahead and just solve for this y. So I'm going to leave the y there, but I'm going to subtract 3x from both sides. And then we see that we're not quite done because y can't be negative, so I'm going to divide all three terms by -1, which will change every single sign. Okay, so I've solved for y. Now, that was step number 1. Step number 2 now says to sub that into the other equation. So, not this one that we just solved for it in. That was our equation right there. So what I'm going to do is sub this in for the y value right there. So I'm going to leave 4x just how it is, -4x. And then I write plus 2, but instead of y, I put what y equals, which is 3x minus 6. And then continue your equation just like it was. So now we have to distribute. Make sure you distribute correctly, multiplying 2 all the way through those parentheses. And then just combine like terms. So -4x and positive 6x is 2x. And then in that same step, let's go ahead and add 12 to both sides. So I will have 4 on the right. Then I have to divide both sides by 2. So I get x equals 2. Now, that was step number 3. We just solve for the variable. But we're not done until we have a coordinate pair. We need a point where they intersect. So my next step is to put that back in and get the second variable. And you can actually put it in here, or even right here, because this is the same as this equation, wherever it's easiest. So I'll just put it back in my first original equation. So I have 3, and then instead of x, I'm going to put my 2 in, minus y equals 6, just coming from my first equation. And so I have 6 minus y equals 6. So if I subtract 6 from both sides, I now have 0. And then, if I divide by a negative, I still have 0. 0 divided by -1 is still 0. So, I now have my y value of 0. So my answer to this problem, my point where they intersect, the x value is 2, and the y value is 0. That is your answer. Okay? Alright, now that's the second way to solve. And let me just show you this. You could see problems in your homework that look kind of like this. And this is still just 2 lines because once again, there's no exponents, there's no radicals, there's no x or y in the bottom. So these are just 2 lines, but that would be a lot of work. So I won't do the whole problem, but I just want to show you a step I would start with. And we saw this earlier, and I told you you'll need it the whole semester. And that is, we want to clear the fractions. And that's legal. You can do that as long as you have an equal sign. So I look at my fractions on both sides of the equal sign, and I pick the least common denominator. and the least common denominator is 4. So now I'm going to multiply, and I'll use a different color so it doesn't throw you as much. I'm going to multiply each oh my gosh, what's it called? Each term by 4, and then reduce. So I have 2, 1, and 2. And then if I write that line, I've got 2 times negative x, which is negative 2x. And here I just have the y, and here I just have the 2. And then let's do it one more time just to make sure we've got it. I look at every denominator and think, what's the smallest thing that 2 and 2 and 8 will go into? And it is 8, so I multiply every single term by 8. And that's legal as long as you do it on both sides of the equal sign. So reducing now, I have 4x and I have 4y. And they reduce right there, and all I have is that negative 1. So that's a much simpler system to use to solve. So do that step if you have fractions, and just get rid of those to begin with. Alright, now let's learn our next method. The next method we have is called elimination. And this is probably going to be our most common method used, because it works when you even have 3 variables, x, y, and z. So let's write down the steps again. What you're going to do is you're going to begin by multiplying one or both, you might have to do it to both, of your equations so that x or y will cancel. And you'll see what I mean. We'll do that in just a second. Then you're going to add the 2 equations together. And what that will do is eliminate one of the variables. So then you'll have the other variable to solve for. And so I'll say solve for the remaining variable. And then lastly, again, you need your second variable. So put that back in, put your answer back in, one of your originals probably, and get your second variable. Okay, so oops, I'm out of the screen. Sorry about that. Okay, so here's an example. We're going to do this one by elimination. Suppose I tell you that 3x subtract y equals 1 and 4x plus y equals 6. Now they start you out like this, and this is kind of nice. They're kind of making it easy because, look at, if you add these exactly as they are, negative y plus positive y will cancel. So the first step, multiply one or both equations so that x or y will cancel, is done for you. And the next one we'll have to do it. But right here, you can add them and they cancel, so it's already complete. So we'll go to step 2, which says add the 2 equations together. So if I add those 2 equations together, you can see that negative y and positive y cancel, so it's gone. But I have 3x plus 4x, which is 7x, and then right here I have 1 plus 6, which is 7. So I just have one variable, and that's what will happen every time if you do step number 1 correct. And so I just divide by 7, and I get x equals 1. So I solve for the remaining variable, done. Now I put that back in my original, one of the originals, to get your second variable. And if you want to check it, you could put it in both, and you should get the same y value in both cases. So I'll just put it in my top one. I'll put it in right there. I have 3 times 1 subtract y equals 1. So solving for y, I will subtract 3 from both sides. So I still have negative 1, but now I have negative 2. And then I'll divide by a negative. So I have positive 2. So my solution to this problem is that the x is 1 and the y is 2. That is the solution to that system, the one point where they intersect. Now let's do one where they don't cancel right off the bat. So let me write it right here. We'll have a tint more space. I've got 2x minus 5y equals 6, and 3x minus 4y equals 9. Now, if you add those up as is, nothing's going to cancel. You would have 5x and negative 9x. So that won't give us one variable to solve for like we need. So I want to look at this and go, okay, I have to either make my x's cancel or my y's cancel. X's are slightly smaller, so let's cancel our x's. So if I want those to cancel, I want to make them the smallest thing I can think of that will be equal. So I'm going to times the top by 3, and that would make that 6x. So in order to cancel, I will have to make this negative 6x. So I'm going to times it by negative 2. So this is what I'm going to do. I'm going to times that by 3, and I'm going to write it right here. And you have to multiply the whole equation, both sides of the equal sign, by 3, or you're changing the line. So to make sure it's the same line, we multiply everything by 3 on both sides of the equal sign. And oftentimes people forget that constant. Don't forget that. Now I'm going to multiply this one by negative 2. So I get negative 6x plus 8y equals negative 18. So adding them up now, I see that my x's cancel, and that's what we wanted. So now I have negative 7y, and this just so happens to cancel. I'll be honest with you, that typically won't happen, but that's okay. We know that y divided by negative 0 divided by negative 7 is still 0, isn't it? And then we're going to go ahead and my bad, I'm sorry, I was looking at my notes. We're going to go ahead and plug that back in, one of our originals. And you know what? You could plug it in here, or here, or here, or here, because this is equivalent to this, but it's bigger, so we don't want that. We'll plug it into one of our originals. And we have to replace y with 0, so I'm going to write, I'll just put it in my top one. And I've got 2x minus 5 times 0 equals 6. So 2x minus 0 equals 6. And then divide by 2, and we get x equals 3. So my answer to this problem is over 3 up 0. That's the solution to this system. And if I were on a test, I would plug x and y in and make sure they equal 6. And here, make sure they equal 9. And I would know I have the right answer for the right answer on the test. Alright, now I want to show you two possible scenarios that are a little bit different and that you could see. So, suppose I gave you this line and this line, and I told you to solve. And let's do this one by elimination as well. And before I even begin the problem, I want to get rid of this fraction. Now there's only one, so you could deal with it if you want, but I don't. So to cancel it, we know we can get rid of it because we have an equal sign. I just have to do it to every single term. So I'm going to multiply every single term by 3. And so now the 3's will cancel here, and I'll have x plus 6y equals negative 3. And then this one, I'll just copy it down. And what you might notice is these are the same, aren't they? But these are different. So let's go ahead and go through the process like we don't notice anything. And let's multiply this by negative 1. So I'll multiply the top by negative 1. So I'll multiplying that all the way through. I now have negative, this is a negative, you can't see it, negative x minus 6y plus 3. Now I'm going to add these two equations together. So if I add those, look what happens. My x's cancel, my y's cancel, but I have 2 plus 3 is 5. Now, we've seen this before, and it's the exact same rule. If your variables cancel, and they did, I have no variables, I look at what's left and go, is it true or false? Does 0 equal 5? And the answer is no. Those are not equal. So just like before, if our variable cancels and the answer is false, or what's left is false, then the answer is no solution. And so they might use the symbol, you might see the symbol, or you can write out the word, no solution. Alright, now let's try one other possible scenario. This is the last one, and you'll have every base covered. Alright, once again, this is my system, and I want to solve. If I'm using elimination, I want to cancel either the x or the y. So let's say I'm focusing on the x's. I can see that they're already opposite signs. One's positive and one's negative. I just have to multiply this by 2, and it will be positive 8. So if I multiply the whole equation, both sides of the equal sign, by 2, I get positive 8x minus 14y equals 20. Now I'm going to go ahead and add those two equations. And if I add them, look what happens. Your x's cancel, your y's cancel, and your constants cancel. So now I have 0 equals 0. But same thing, if my variable's gone, I look at what's left and I say, is it true or false? Does 0 equal 0? Yes, that's true. If it's true, before we said all real numbers. But you have to remember that what we're talking about here are two lines, and what must be happening is they're the exact same line on top of each other. So one line's on top of the other line. So this is a solution, this is a solution. Every single point on that line, infinite directions, is a solution. So there are infinite solutions, and some books just say that. They say infinite. Not all real numbers, because this point is not a solution, is it? The points that are solutions are on the line. So there are infinite solutions. This book writes it like this. It writes their squiggly brackets, and it says that x and y are such that, that's shorthand meaning are such that, x and y are such that, and then they just pick one of the lines, usually the top one. They are such that they are on this line, close bracket. So that's how you write it. Before you just wrote all real numbers, but now once again it's not all real points, because every point's not a solution, but there are infinite solutions on that line. And this is how our book tells us that. It says x and y are such that they're on a line. Alright, that's it. This is an important section because you have to be able to do this before you can do 3 variables, which is coming up. So get that done and make sure you know it.